Hello and welcome to this lesson about divisibility rules. The learning target of this video is know how to determine if a number is divisible by the numbers 2 through 10. So these are some rules you're probably familiar with, but I want to go over them just because as you continue to progress throughout mathematics, it's really important to be able to break numbers down into their building blocks. And so we'll start off with the divisibility rule for 2. That one's pretty easy. Anytime a number is even, it's divisible by 2. For the number 3, it's a little more complicated. Its rule is the sum of the digits of a number is a multiple of 3. So let me explain what that means. It's a multiple of 3. So now this works out great for like larger numbers, but let's use a simple number to highlight this example. Let's say we take something like 27. Now we know that 27 is a multiple of 3, but what we can do is, if we're unsure about it, is you take those two digits, 2 and 7, you add them together and see what you get. Now, this is the question right here. Is this one a multiple of 3? And it is. So 9 is a multiple of 3. Now, again, works great for smaller numbers, but as we get to larger numbers, it helps us determine whether or not a number is divisible by 3. So let's say we take something like 462. Is that number divisible by 3? I don't know off the top of my head, but what I can do is expand it, add its digits together, and see what I get. 4 plus 6 is 10, plus 2 is 12. So I've taken this 3-digit number and I've reduced it down to something that I know is a multiple of 3. So yes, that's a multiple of 3. Therefore, I can divide this number by 3, and I will get a whole number answer. So that's how we know if something is divisible by 3. Let's now talk about the divisibility rule for 4. So for 4, it's all about, are the last two digits divisible by 4? Are the last two digits divisible by 4? Divisible by 4. Now again, if we're talking about numbers that are less than 100, all right, it's kind of easy to determine whether or not it's divisible by 4. So we know that 66 is not divisible by 4. So it's not, because those last two numbers are not. The last two digits are not. But if we were to kick it up a notch, like 166, maybe it's divisible by 4. It's even. I don't know. But yeah, if I just look at the last two digits, that's how I determine whether or not a number is divisible by 4. So if I then switch it to the number 188, it is divisible by 4 because 88 is divisible by 4. And so again, as we continue to make these maybe a little more complicated, and we extend the numbers and make it larger, so instead of it being 188, it's now 3,188 or 63,188. Instead of having to do the division throughout the entire number, we're looking at 2 digits. All right, rule for 5, that's an easy one. The number has to end in 0 or 5. So number ends in a 0 or 5. End of story. Nothing fancy there. And that's what's kind of nice. Some of these rules start to build on top of each other. So for example, 6. It has to be even and divisible by 3. So let's take something, like the number we saw earlier. What was it? 462. Well, we do a divisibility test, and we're like, okay, let me do that 4 plus 6 plus 2 thing. Okay, that equals 12. Okay, so I know it's divisible by 3, but since it's an even number, looking at that last digit, it's an even digit, it's also divisible by 6. So that's a neat little shortcut. All right, now, are you ready to have your mind be blown by this one? Okay, 7 has a really weird rule, but it totally works. So what you have to do is double the last digit and subtract it from the rest. If the result is divisible by 7, then the whole number is. The number is. All right, so let me show you a real simple example. All right, so let's take a number like 91. Now, I know 91 is divisible by 7. Maybe you don't, or do not. Doesn't matter. But the way this rule works is I take the last digit. I'm going to then take that 1 and I'm going to double it, meaning I times it by 2 to get 2. I take this number now, that 2, and I subtract it from whatever is left. And what I end up getting is 9 minus 2, which is 7. Since this is divisible by 7, since that's a multiple of 7, the whole thing is divisible by 7. I know, totally weird rule. All right, let's see here. Let's do another one. And then the way these tend to work is something like this. Let's look at the number 126. We take off that 6. We're going to double it. So 6 times 2 becomes 12. And then I go 12 minus 12, which is 0. 0 is divisible by 7. So that works. And if I were to adjust it just a teeny tiny bit, so if I went like 123 and I tried this exact same thing, so 123, I take that 3, I double it, I'll get 6 this time, subtract 6. As a result, I get 6. This is not divisible by 7, so the whole number here is also not divisible by 7. All right, then we got 3 more to go over here. So 8, it's a similar rule to 4, except it's now the last 3 digits have to be divisible by 8. And so we're really talking about a large number, but odds are at this time you're going to use the even rule to see if it's divisible by 2 over and over again. But just that is the rule for 8. Number 9 is another variation of the rule for 3. So the sum of a number's digits is a multiple of 9. So for example, let's take something like 297. We're going to expand this open to go 2 plus 9 plus 7. And what we end up getting is 11 plus 7, which is 18. 18 is a multiple of 9, so this number is also divisible by 9. All right, and then final one, let's say we have something like 10. That's an easy one. Has to end in a 0. So these are the divisibility rules, and these are just meant to help you be able to break down numbers so that way you can use them. And you can use their components to find maybe something like a least common multiple or a greatest common factor. Let me know if you have any questions, and good luck on your homework or practice.